Hi students, if you are studying the chemical kinetics and you find difficulties, then this is the video for you. Okay, here we are studying the kinetics of the photolysis of acetaldehyde, how the photolysis of the acetaldehyde happens, which is the mechanism of this thing, and what is the quantum yield. Okay, how we can understand the quantum yield. This whole thing we will understand this video. Okay, so let's start this video. Try to understand. Full courses are available on our app. You can visit the link. Link is given in the description box. So first of all, we are starting from some key points about the photolysis of the acetaldehyde. Actually, first thing was that the quantum yield increases with increase in the temperature. It means as you are increasing the temperature, the quantum yield increases. Okay, and the quantum yield of carbon monoxide formation increases with decreasing the wavelength. It means if the wavelength is decreasing, then the quantum yield is increasing. And the third thing is that the quantum yield of carbon monoxide formation at room temperature increases with decreasing pressure at 3130 angstrom. Okay, means as you are decreasing the pressure, then the quantum yield is increasing. Okay, and the fourth point was that the photolysis of acetaldehyde in light of 2500 to 3100 angstrom wavelength. It means such a wavelength light if you are taking, then the photolysis of acetaldehyde yields methane, CO, ethane, and number of other products. Means this reaction is actually happening in this manner. See here, CS3COH in the presence of light get dissociated and it forms methane, ethane, CO, and other products. Okay, so this reaction is happening. Now, to account for this reaction, actually, what mechanism was supposed to see here? This is the mechanism for the photolysis of the acetaldehyde. That will give the answer of all of these points. Okay, so actually, this happens in the some steps. Step number 1 is CH3CHO. In the presence of light, it forming CH3 plus CHO. Okay, rate constant here will be given by K1. Second step is this CH3CHO is now reacting with CH3 and it is forming CH4 plus CH3CO. Okay, now in the third step, what is happening? This CH3CO. This is the rate constant K2 for the second step. Now CH3CO in the third step is dissociating and it is forming CH3 plus CO. The rate constant here is K3. Again in the next step, what is happening? This CH3, okay, is reacting with another CH3 and it is forming C2S6. Okay. Now, see here, these reactions are happening in the 4 steps and now you can see here, this is CH3 that is formed here and it is utilized here. Okay, again it is formed here and utilized here. It means CH3 is an intermediate, so we can apply the steady state approximation to it. Okay, second thing that you are seeing is CH3CO. Okay, this CH3CO is being formed here and utilized here. So we can also apply the steady state approximation to CH3CO. Okay, rate of formation of CH3CO. We can apply steady state approximation. Now the products that are being formed here are, one, you are getting methane, another you are getting carbon monoxide, and third one you are getting C2S6. Okay, so first we are seeing the rate of formation of the CO, carbon monoxide. Actually, this is the thing that we have to see here. Okay, so carbon monoxide, you can see, again see here. See here, carbon monoxide is formed in the step number 3. Here, in the step number 3, you can see carbon monoxide is being formed. So the rate of formation of CO. So the rate of formation of carbon monoxide is given by step number 3. It means BCO upon BT. This is the way in which we are giving the rate of formation of CO. So it is given by K3 CH3 CO. Okay. Now you are getting in this manner. Okay. Now here you are getting CH3CO. That is an intermediate. Actually, it is an intermediate. I have told you it is formed here and it is being utilized here. So we can apply the steady state approximation to its concentration. Means to say we can write d CS3CO upon dt will be equal to 0. Actually, it is given by, it is formed in step 1. So, K2CS3CO CS3 concentration. Okay. Here we have taken plus sign because it is formed in this step. And then minus K3 CS3CO because it is being utilized in the step number 3rd. So now you can write this is your equation number 1. Suppose this is the equation number 1. Okay. Now similarly, one thing you should see here. You are getting here CS3 concentration, this one you are getting. So actually you will have to find out the value of the CS3 also because I have told you that you cannot take the intermediates in the rate law. Okay, so you will have to find out the another term in place of this. Okay, actually we know that the CS3 is also an intermediate. It is being formed in step number 1. It means step A and step C. Okay, and used in step B and D. So we can again apply steady state approximation to it. So what you are getting? You are getting dCS3 upon dt will be equal to 0. And actually it is given by, in first step it is being formed. It means K1 I absorbed plus K3 CS3 CO minus K2 CS3 CHO CS3. Okay, in steps B, it is being utilized. So minus sign we are putting. And in the step 4, it is being utilized. So minus sign again we are substituting. And this will be equal to 0. So this is our step number 2. Okay, equation number 2. Now, by adding equation number 1 and 2, when you are adding these two equations, two terms will get cancelled out. Okay, you are getting, what you are getting? You are getting K1 I absorbed minus K4 CH3 whole twice is equal to 0. Okay, or you can write the concentration of CH3 is equal to K1 I absorbed divided by K4 to power half in this manner. Okay, now you can substitute this value in equation number 1. What you are getting? You are getting K2 CH3CHO K1 I absorbed upon K4 to power half minus K3 CH3CO is equal to 0. This you are getting. Okay. So you can put here K3 CH3CO will be equal to K2 CH3CHO K1 I absorbed divided by K4 to power half. Now you can find out the value of CH3CO. Okay, you have to find out the concentration of actually CH3CO because it is given in the rate law. So you can find out it from here. So you are getting K2 upon K3 CH3 CHO K1 I absorbed upon K4 to power half. Okay, now you can substitute this value. Okay, you can substitute this value. So you are getting dCO upon dt. This you have seen in the first number equation. You have seen this thing when we have written the rate law. Okay, this we have written. So we can write here K2 CH3 CHO K1 I absorbed upon K4 to power half. Okay, or you can take the rate constants on the one side. Okay, so you can write K2 K1 upon K4 to power half, and you can write CS3 CHO then I absorbed to power half. Okay, or you can write one term of all these constants. You can write this is a constant, that is K. So you can write K CS3 CHO I absorbed to power half. Okay, this is the value of dCO upon dt. All right. So this is the thing that you have to find out. It means now from here one thing is clear, that the rate of formation of the carbon monoxide depends upon the concentration of CH3CHO, one order, and on the value of I absorbed to power half. Okay. One important thing here is the quantum yield. One more thing, if you want to find out the rate value for any other, suppose you have to find out for the methane or for the, you have given C2H6, you can find out similarly. Okay, same thing you have to do, you can find out that also. Because sometimes in the question papers you may have asked in another way. Okay. Now, one important thing here is the quantum yield. Actually, directly questions are asked from the rate law or from the quantum yield. So, quantum yield is actually if the rate of formation of carbon monoxide is divided by the intensity of the absorbed radiation. The value of quantum yield is obtained. Means to say is what? Quantum yield is equal to dCO upon dt. Okay, divided by the I absorbed. Just you have to divide it by the I absorbed. Now you know its value, so you can substitute K I absorbed to power half CH3CO concentration, CH3CHO concentration, okay, divided by I absorbed. So you are getting this will be equal to K CH3CHO divided by I absorbed to power 1 by 2. Okay, this is the value of the quantum yield. Okay, so whenever you have asked about the quantum yield, what you have to do? You have to divide it by the radiation's intensity of the radiation. Okay, you will have to divide the rate by the intensity of the radiation. You will get the quantum yield. Okay, so this is one of the important things from this discussion. One thing is clear, that the quantum yield of carbon monoxide formation increases with decrease in the light intensity. Alright, so this is about the photolysis of the acetaldehyde. Similarly, you can find out the thermal decomposition of the acetaldehyde. In a similar way, you can find out. I will give you the question based on this so that you can understand this thing also. Okay, and if you find any query, okay, this is the quantum yield, the thermal decomposition of acetaldehyde. Same manner pattern will take place. Okay, so same things are happening. You can do the different types of the equations in a similar manner, and if you find any query you can directly comment me. Okay, so please comment me and keep on learning. Okay, so meet you in the next lecture. Thank you.